Hello, hello, going live. Hopefully everybody can hear me good. I can't yet see how many viewers I am at. I assume there's nobody in here. But leaking a little bit what I was going to show today. But yeah, so I started off the stream, or sorry, I ended the stream last night. Finishing part one of this lanternfish problem, and I'll go over it in a second. But there's a little bit of a bait, or in Twitch speak, maybe you want to call it a jub bait, that the writers of these problems pulled on us to a certain degree, or at least pulled on me, and it was successful. So I'm going to go over, I finished it pretty shortly after the stream yesterday night. But I want to go over my solution. I've cleaned it up a little bit, and then I want to show you some benchmarks because that's important to the sleight of hand that these writers were playing. So we're going to be doing that. So yeah, so first to go over the problem. So the seafloor is getting steeper. Maybe the sleigh keys got carried this way. A massive school of glowing lanternfish swims past. They must spawn quickly to reach such large numbers, maybe exponentially quickly. And they bold words for a reason, right? And I was a little naive as to why this word would be bolded. It became evidence that it is an exponential problem, but I should have taken this a little more into account with my solution. They must spawn quickly to reach such large numbers, maybe exponentially quickly. You should model their growth rate to be sure. Although you know nothing about this specific species of lanternfish, you can make some guesses about their attributes. Surely each lanternfish creates a new lanternfish once every 7 days. However, this process isn't necessarily synchronized between every lanternfish. One lanternfish might have 2 days left until it creates another one, while another might have 4. So you can model each fish as a single number that represents the number of days until it creates a new lanternfish. Furthermore, you reason a new lanternfish would surely need slightly longer before it's capable of producing more lanternfish, 2 more days for its first cycle. So, suppose you have a lanternfish with an interval timer of 3. After 1 day it becomes 2, after another day it becomes 1, after another day it becomes 0, after another day it would reset to 6, and it would create a new lanternfish with an internal timer of 8. After another day, the first lanternfish would have an internal timer of 5, the second would have 7. So just a little bit more specifics. Realizing what you're trying to do, the submarine automatically produces a list of the ages of several hundred nearby lanternfish, which is your puzzle input. For example, suppose you were given 3, 4, 3, 1, 2. This list means that the first fish has an internal timer of 3, the second fish has an internal timer of 4, and so on until the fifth fish, which has an internal timer of 2. Simulating these fish over several days would proceed as follows. And they make it very clear how this works in a really nice visual way. I have to give it to them. It's like if you didn't understand the problem before, it becomes very clear here. And I don't want to call it a major blunder, a major misstep, but something that I did yesterday was I took this approach very literally. So what I did was I took the input, I created a list of those, and then I just iterated through it for X number of days. I'll show you the code in just a moment. And just followed those rules, appending to the end, and adding new fish, decrementing the fish that haven't been counted yet, and working that way. So they go on to explain a little bit more, explaining what exactly this picture means. And then in this example, after 18 days, there are a total of 26 fish. After 80 days, there would be a total of 5934. So find a way to simulate lanternfish. How many lanternfish would there be after 80 days? So just to be clear, they're not talking about the 80 days that's just preceding this in the question, but given your input file, how many would exist after 80 days? And little spoiler, there's a lot more, but that didn't create a huge amount of issues for me. So this code's slightly wrong, but the way I went back and checked the stream before I changed anything, but I basically ran my program just like this. So can I scroll? Yeah, I can scroll down on this. I want to hide something for a second. Oh, it's not letting me. But I called this one first attempt. I moved it over. So we get this answer. That was correct. So this is relatively trivial to compute, as was probably pretty clear there. We're talking about like minimal lag between me hitting enter. I don't know if you can hear my keyboard, but between me hitting enter and so Python's not a compiled language, but for the interpreter to run the file, execute all of these instructions for 80 days, and then move on. So I want to illustrate something for you. And then we'll scroll up to that thing that I'm somewhat hiding. So see, we reach 80 in a relatively short amount of time. Now what happens if, say, we do 100? It starts to slow down there. We're not talking about like minimal lag. And I think there's a reason they picked this number specifically, probably based on like the not optimal way, but the assumed way of solving this, and tailored the number of days based on that. I mean, 80 is a round number, but that's my guess. Is like, and this is a relatively performant MacBook that I'm running this on, with an i7 mobile GPU, but an i7 GPU. And Python's only running single core to begin with. Unless you specifically tell it otherwise. But we're talking about a fair number of instructions per clock and a high clock speed at turbo. So this is going to run faster than a lot of computers are, but it doesn't run quite fast enough. So when you scroll down to part 2, suppose the lanternfish live forever and have unlimited food and space. Would they take over the ocean? This is just extra story. After 256 days in the example above, you get this massive number. Before it was 5934, and now it's this. I don't know how many digits that is. I'm not going to count them, but it's a massively large number. And it's still quite a bit smaller than this one that took maybe 5 seconds to run. And knowing that every day we have to iterate through, change the value of every single fish's counter, and then add on to it, and it gets longer every day. Right? And like no fish ever die. So I just want to, and I illustrated this on stream last night if you were watching, but relatively low on viewers yesterday. So that's partially, what's up, Devil Squirrel? So partially why I'm going over it again. So this is what happens when you try to run 256. I let this run for quite a long time last night, and right around 100, I mean, it's a curve, right? So you can't really define where it hits a wall. But once it gets around like 150, 160 on my PC, we're talking about like probably a minute between additional days being computed. So I'm going to Control-C out of this. I hope my scroll back goes far enough. But I wanted to show that I benchmarked. So there's this really cool utility. I'm a big fan of Rust. I'm trying to learn it a little bit right now, but I'm a big fan of the Rust as a technology. Don't know a huge amount about it in terms of a programming language, but possibly something that supersedes C in the near future. And somebody can correct me on this, but I'm fairly certain that I read this. But Linus Torvalds, the main maintainer, I think until recently actually, but the main maintainer of Linux and the Linux kernel was saying that he would accept pull requests based in Rust into the Linux kernel strictly if they were for security-related reasons, because Rust is very good on memory safety, and some, let's say 70%, you can look up and see exactly what it is, but I want to say the figure I've heard is about 70% of vulnerabilities are based on memory, what are they called? Not memory out of bounds, but memory safety related issues. So that was his reasoning for doing so. Mini tangent, but there's this program called Hyperfine. It's written in Rust. I really like Rust drop-in replacements for stuff. Some of the people with more acute eyesight might have noticed I have an abbreviation within ZSH, that my ls is actually EXA, which is a Rust drop-in replacement for ls. It's why my ls command gives all the colors, and I can show that in a second. Also a big fan of fd, a find replacement, rg or rip grep, grep replacement, etc. But big fan of Rust programs, and I want to start programming in Rust. Maybe by the end of this project, I'll maybe be working with some Rust stuff. But yeah, actual end of the tangent. Hyperfine is a benchmarking utility that allows your program to run like X number of times, and you can set a warm up, and it benchmarks on average with ranges and outliers and all that stuff. So this was set with 128 days, and this was on my first attempt. It takes 44 seconds. And just for reference, you can't see it here, but 80 days on both my old solution and my new solution, which was what part 1 was, gave me like sub 1 second, like I think 800 something milliseconds. Actually, my new solution is tick slightly longer, but I will explain why I believe that is in a second. Just some extra overhead that's built into the application. But yeah, so I ran first attempt.py, which is the file and the approach that I was describing before, with a warm-up of 10 cycles, probably a little overkill, but just make sure you're boosting your CPU, or you get the boost out if it's not going to continue sustain, so you have less outliers. Took 44 seconds, plus or minus 2.19 for the standard deviation. And my new solution takes 1.255 seconds. And I will go over that solution in a second. But basically what happened yesterday, and it took me a little longer than I expected to realize. I thought maybe I could just sit through and use my naive solution and let it continue to 256. But it became abundantly clear that that wasn't going to happen. I'd be interested to see somebody that tried to let it run with said naive solution. I'm thinking with the way exponentiality works, potentially like a whole day, maybe even multiple days for it to complete, and calculate over 256. So to talk about my new solution, so I'm leveraging pandas and numpy to do this. I changed how I was loading stuff in slightly. I did a little bit of research when I was cleaning this up about some of the issues that I was having about like clearing white space and stuff before I was doing like a dot replace new line, replace it with just like a empty string. But there's something already built for this that you can use with Python. It's called rstrip, and it just strips out any white space within a given string. Oh, yeah, thank you. Sorry, I meant to make it bigger. But thank you, Devil Squirrel. Appreciate it. Oh no, I hate it when this happens. Okay, there. We're looking good now. Cool. But yeah, thank you for the heads up. I'm glad someone's in here checking me on that stuff. So what I do is leverage a NumPy array, and the reason being is it makes it slightly faster for the step that I'm just about to explain, but the real majority of the work is being done more with the algorithm than the actual appliances within Python that you're using. So this part doesn't hugely matter to that large performance increase. But I use a list comprehension, another cool way to do some of the stuff I was struggling with before, but you cast to an int, create for x in f.read, and then you strip all of the white space. So that's just taking new line characters off. And then split by commas because they're comma separated values. That's already a list, but then it's just iterating through, casting it to an int, putting it in the list, and then that's being passed to a numpy array. And then there's a fish data frame. That's what I'm calling it. Usually anything with pandas data frames are either df or have df appended. So fish df is PD, which is pandas alias data frame, and then just for my debugging, and this isn't explicitly necessary, this could be just done slightly differently, but done as a bare one-dimensional numpy array. But what this allows you is to have all of the columns labeled. Even though you can count the indices, it's nice to have like the little header above that tells you this is the number of days. Basically, the counter of the fish is. Sorry, there's two different kinds of counters here. So this is the number of days the fish have left until they spawn, given the description that we read before. And then within the actual data frame, it's only one line, and that's the reason you don't really need a full data frame for it. It's more meant for 2D table data, but is the count of fish that are on that number of remaining days. And that's populated with 4x in range 9. What's it called? The index of that day, similar to the same thing as the columns, or you're looking it up by columns, is the length of the NumPy array where fish is equal to that value. And then the 0 is just because you only have one row in this case. And the reason you have to do length is because it just creates this command within the parentheses just creates a smaller NumPy array, which is all of the fish that are of that size, and then length computes how many there actually are. And there's probably a more performant way to do that because it's kind of doing two steps where you really only needed one, but that's a potential optimization. And as I was talking about before, a potential reason that at 80 days, this one actually ran slightly slower than my other attempt. I'm not going to have time to show the printouts, but I had them here. It returns the fish df down in main, and then I have a grow function. I take a deep copy, and I forgot to check whether I need a deep copy of it. And I'll be honest, I don't remember exactly, but I knew that deep would be more than fine. Whether or not it was required, I don't know. But saving a copy, it's basically what the previous day was. So then for x in range 1 through 9, so actually 1 through 8, you're going to deduct a day and append that to the number, and then you're going to subtract that number of fish from the previous day. Remember, this is a copy. So it's basically doing that a left shift for everything but day 0. And including day 0. And then of the new day's data frame at index 6, it's going to be equal to all of the ones that were at 0 previously. And then for also adding that to all the ones with 8 when they spawn a new fish, and then subtracting any existing zeros that were there before, because you can't start a day with 0 fish. It's kind of hard to explain, but they become a 0 within that day, but they don't start the day at 0. They start at 6. So return that data frame, and then for days in 128 in this case, when I was showing the benchmark, but the real version would be 256 and 80. So you load fish for D in range days, you grow the fish data frame, and then it prints out what the population is of the fish. This is just the way you would have to do it, the way that this data frame is formatted, is blah, blah, blah. So running this, so you see it took, instead of 45 seconds for 128 days, we're able to get both 80 days and separately calculate 256 days in some small amount of time. So if I run hyperfine on that, and this will be like the last thing I can do before today's problem is released. I didn't leave quite enough time, partially tangents and stuff. But this should finish by the time the new question comes out. Devil Squirrel, I would love to, I can also look at your GitHub because you sent it the other day, but I would love to see exactly how this recursive solution worked, because you made it seem like it was something different than the way I was attempting to approach it last night and the way I approached it this way. But I would love to talk about that if you'd mind sharing. I can also look into your GitHub specifically and see if I can figure it out. But yeah, just preparing. Oh, interesting. Yeah, I will think about that after today's problem and discuss it if you're all right with that on stream after that, if I'm not too fried. But the average time was 2.8 seconds for 256 plus the 80 days. So minus what I know the 80 days was, it's about 2 seconds versus what I think would have taken like multiple days. So overall, very good. But yeah, let's prepare. Good luck. 30 seconds left. I don't want to be like racing these as much anymore. Probably because my race speed is not too good. But yeah. 6 seconds left. Let's go. Make this a little bigger as well. No, too big. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. You quickly make a list of the horizontal position of each crab. Your puzzle input. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions: 16, 1, 2, 0, 4, 2, 7, 1, 2, 14. This means there's a crab with a horizontal position 16, one with 1, and so on. Each change of one step in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all, but the one that costs the least fuel is horizontal position 2. So you move from 16 to 2, which costs 14 fuel, then 1 to 2, which costs 1 fuel, then 2 to 2 because there's 2 at that horizontal position, then 0 to 2, oh, I understand what's happening, and then 0 to 2 costs 2 fuel, 4 to 2 costs 2 fuel, 2 to 2 again costs 0 fuel, 7 to 2 is 5, blah, 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 and then moving from 14 to 2 costs 12 fuel, so this costs a total of 37 fuel, and this is the cheapest possible outcome. More expensive outcomes include aligning at position 1 for 41 fuel, position 3 for 39 fuel, or position 10 for 71 fuel. Determine the horizontal position that the crabs can align using the least fuel possible. How much fuel do they spend to align in that position? So let's start. I'm beginning to think it makes more sense to just use test input first, and then we can work on scaling up the solution. So some of the code, as you probably saw before, can be, let's delete first attempt, and we're gonna delete a lot out of this. I don't think a NumPy array is super necessary, so I'm gonna delete this grow, and we don't want to open input, we want to open test. I don't think the NumPy array is really going to net us much here. So this gives us all of the crab's positions. So based on yesterday, it kind of gives me a little bit of information about how I should approach this. My immediate thought is that I just try out every single one. Maybe I still do that for part 1, because what I'm thinking may happen is it may create a similar situation to yesterday, where the input gets much larger and calculating all of the permutations of where you start is going to be too hard, but I don't think it's necessarily the right approach to do that. And assume that that's going to happen and spend a lot of time building it when they could throw a big curveball. I guess this is the only thing that says fish. But, typing's not on point today. So we load crabs up, and then, max crabs is equal to max of crabs. I'm pretty sure that works if it is an int array, but we'll see in a second. Oh, I called it crab, but not crabs. Should have seen that error. Oh, I need to print it. For some reason, B is really hard to hit for me today. I'm not sure why. Yeah, okay. So it does return the max. So you would go for I in range, max crabs, plus 1, because this would go from, in this case, it would be from 0 to 15. It's not 16, it's 16 exclusive. So you would want plus 1 because there's actually 17 different starting positions, or like horizontal positions, whatever you want to call them, in this case. So for that reason, you would want to pick plus 1. And results equals a list. Fuel count equals 0. For crab in crabs, fuel count plus equal to, yeah, did that right the first time, plus equal to the absolute value, because we're going to do a subtraction. You don't want to add a negative number. But given a certain starting position, it's going to be I minus, so it's the absolute value, the distance, I minus crab, and its horizontal value. And then when that's done iterating, you would just append fuel count. Actually, that reminds me, I probably should check the input here. Yeah, so it is a massive number. We'll see. That's too hard to compute in a moment. And then we can go back to the drawing board. But yeah, it's shouldn't be that hard with this, but and then best line is going to equal to I think it's, what is it? It's results dot index the min of results. Wait, why did it expect? Oh, I see why. Sorry, print. Well, so that was pretty quick for the small one. I'm afraid it's going to be a lot bigger. Oh. Oh no, so that's correct. So horizontal position 2. Oh, and we need to give it the fuel. The fuel required. So, oh, so it'd just be print min result. So the best line isn't really necessary, but yeah, it gives you 37. I'm minorly afraid what's going to happen when I try to do this with this bigger one. We're talking about a much larger iteration. But we'll see. And so there's definitely a big enough input file where it could be really rough. Okay, that was pretty quick. 333755. Cool, that was the right answer. The crabs don't seem interested in your proposed solution. Maybe you misunderstand crab engineering. As it turns out, the crab submarine engines don't burn fuel at a constant rate. Ooh, fun. Instead, each change of one step in horizontal position costs one more unit of fuel than the last. The first step costs 1, the second step costs 2, and the third step costs 3, and so on. Each crab moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. So it creates 100. This costs a total of 168 fuel. This is the new cheapest possible outcome. The alignment position now costs 206 fuel instead. Determine the horizontal. So it's the same idea again. So basically, what we have to implement is that the fuel cost is, it's not the absolute value. It'd be calculate fuel. Define calculate fuel. Distance for I in range. Distance fuel counter is equal to 0. So fuel counter is plus equal to I. So let's try it with the test input. That's an educated guess. I feel like I might have oversimplified this though. Yeah, I did. Oh. I need to take into account. Is that why? 123. Okay, no, I'm screwing something up still. So from 1 to 5, that's a distance of 4. Oh. I think I know why. That should be 1, and then it's absolute distance plus 1. 168. So I'm pretty confident. It's going to take a lot longer because it's iterating through like I would use like a factorial function because I'm sure that's better optimized, but it's not factorial. It's like the addition version of factorial, which I don't know if that's like a concept that exists. Okay. I feel like they might have done the same thing to us today. So just so I can see. It was at like 500 something before. I think that was like the largest number I saw. 468. Oh, 1106. 1800. So anything higher than 2000. Like, I don't think this will take too long. But at least it's not exponential. So like every iteration theoretically is going to take the same amount of time. That's not exactly true. The ones that are going to be the worst solutions are going to take more time because that for loop needs to iterate more times. But unless I'm completely mistaken, I don't think. Well, I mean, it's definitely not going to take exponentially more time each round. But for the most part, it's on average, it's constant time. Well, I guess you could say the same thing with yesterday's solution. Yeah, I'm just waiting for mine to compute right now, Devil Squirrel. You beat me to it a little bit, but we're just waiting for it to finish iterating. The highest number I saw was like 1800, so it should be almost done. I was thinking maybe it was one where we needed to do like a little bit of a cheekier solution, like yesterday, but clearly not. I mean, this is still taking a little while, but that must not be the largest number. Okay. But I'm relatively confident this is correct. So don't type it in wrong, Connor. 94017 638. Cool. That was the right answer. So pretty good today. So I'm curious. What? You gotta fix your stats. So probably in the 4,000-ish. That's whack. Maybe everyone's checking their personal stats at once. Oh yeah. I think it's a load issue. Everybody just wants to see right after they put it in. That's my guess. But yeah, no, it was quite a bit simpler than yesterday's problem. It's really weird. Can you load the personal stats, Devil Squirrel? I'm curious. I assume it's just load on the website. Plus people like attempting. Depends on how they do like load balancing and stuff. If they give more precedent and more nodes, if that's how they're doing it, okay, yeah, as did I. That's weird. It spun for so long to give me an internal server error. It just depends, I guess. But yeah, I assume it'll be back up eventually. So I assume yours was not any more optimized than mine, right? All I did was instead of just doing the absolute value and adding that to the fuel count, because that's like its distance from like the whatever given track you're picking. Instead, you do an iterator from 1 to the absolute value of the distance again, plus 1, and then add that to the fuel counter, and then return that. Yeah, I'm curious how you optimized it a bit more. I'm sure there's like, I'm not super good with algorithms, but I assumed there was a more optimized version. But I think the big optimization would come in part 2. I don't think there's any real, well, maybe there is a better way than just checking every single vertical or horizontal, whatever. Well, they're horizontal distances, so I guess it'd be vertical. Because it's like the boat. But do you mind if I pull your GitHub up on stream? I'd love to see. Checked in. Oh, you don't mind if I bring it up, right? Okay. I think you're. I was telling my manager today about the guy who's always in the stream. I really enjoy that you're here, by the way. No hate, but he thought your username was pretty funny. Updated 30 seconds ago. Wonder why. So here's going to be the problem. I don't know how to read C# very well. But let's see if I can figure this out. Make it a little bigger for the people in the back. Hopefully that's big enough. Oh, I don't know. GitHub's not perfectly responsive, but it's somewhat responsive. So hopefully that's big enough. It's your code, so I assume you don't care. You just count the number of crabs. Oh, I see. Yeah, I guess that's optimization. Do you create like a 40 to the length? So you kind of solve it in a way how I solved it yesterday. Instead of just treating every number as a unique one, you create like a counts, and then you just figure out the distance to that distance, and then you like add like X times that count. In the setup. Yeah. So yeah, I guess that is definitely a more optimized solution. This was a bit naive, and I'm sure that's to some degree why mine took a little bit longer to run. And the reason being is like, say you have 40. I don't think there's that many, but say you had 40 at distance 11. You're moving through this iterator 40 at 11, and then like the distance is like 200. You're doing like 240. Did I pick easy enough numbers? 8,000 extra. Yeah, 8,000 extra like iterations of this, like clock cycles that weren't really necessary. But on the flip side, theoretically, it might actually be slower, I would assume, on the test input. Not that that matters, but because there's the upfront cost of calculating the counts of your input values first, but with enough crabs, it's always going to pay off to do that. So yeah, I might implement that because I'm done real early today. Definitely starting to get a little fatigued with streaming so much. I'm enjoying it, but I checked my stats, and in the past 6 days, so today's the 7th day, but before today, 12 hours of streaming in the past 6 days, averaging 2 hours a stream, and decent engagement, I feel like, for my first week. Yeah, I feel good about it, but I would love to get more people in here, so eventually maybe that will happen. But yeah, I think what I'll do is I'll implement a solution. So let's benchmark this first. Let's not even do it with... Well, I already changed it. Absolute value of I minus crab. Give it 10 warm-ups, which even if it's doing 10 iterations, 10 warm-ups is a little overkill. But I really like how like nice the user interface is for this. So on average about 1 second. 1.01. And I'm always down for suggestions as well. If like going through things like this, like implementing it a different way is or isn't useful for anybody that's here. Or I don't know if you can post an offline chat, like when you're watching a VOD, but in some way, if you can figure out a way to contact me, I'm always down for suggestions. I want to make the stream as nice as possible for the viewing experience. So this one takes, okay, I do not want 10 warm-ups for this. It's not just do 2. So 12 iterations total. This is going to take a while. So I'm going to work on how do I implement this? So crab counts equals for I in range max crabs plus 1. Do you have any interest in learning Python, Devil Squirrel? Or DS? I said I was going to call you that yesterday. But you said it's interesting to see people in other languages. But I'm curious if you have any interest in learning Python at any point. If you're still here. I think that was from a while ago, right? Yeah. Um, yeah, I will admit I'm probably not the this is where my like knowledge of Python doesn't necessarily show exactly what's possible. The one cool thing, let's fix this error so it's a little less cluttered, but Python has this concept of list comprehension. So lists are there's slight technical differences between this and like an array in other languages, but it's essentially your array data structure. But you can instantiate, and the cool thing about Python is for the most part, like you don't really need to know Python syntax in order to understand what it's doing, but you can create a list as like one-liners like this. So this is the iterator. So for x in f.read r strip split, what that's doing is it's just like the f to the end is just creating a list of all of the numbers as strings because it was read in from a text file into a list construct. Each element is something that's separated by a comma, and then you iterate through this again. So for x in that list, you can cast it to an int. So like that's a really cool thing that you can use. Okay, I mean you're enjoying watching me do it. I think it's definitely a nice Python's a nice spectator sport because for a lot of the time, once you get into like interesting other libraries, it starts to be a little bit more convoluted. But for the most part, you're like watching people write pseudo code a lot of the time. At least when I was trying to learn Python, like it was really, really useful because like for the most part, it was, like I said, just like watching somebody write pseudocode with a little bit of extra syntactical sugar, but relatively easy to read. But there's not a bunch of brackets to get in the way. There's not semicolons, all that kind of stuff. It does fail on the other end of the spectrum, like there's issues with dynamic typing. And Python's adding that, I believe, either added that or will be adding like type annotations, so not full typing, but adding type support in a more explicit way. So debugging can sometimes be a pain in the butt because it's dynamically typed. The strict indentation, I've begun to like it, and I think that it really helps me write code in other languages when I do that, which isn't super, super often. But when I was doing it in school, it definitely helped me write clearer code because I would, for the most part, indent in the same way I do in Python. But yeah, there's my little spiel. So yeah, we still haven't finished the benchmarking, so we got a little bit of time. So what I'm doing is just so I can use the same syntax as I used yesterday, I'm casting this crabs list into a NumPy array, which is like a scientific computing library, which gives it like true array with all of the time complexity benefits of a true array to Python. And then what builds off of that is the pandas library, which is used, it's like anything that you touch within data science is going to use, I'll say 99% just in case I'm wrong, but it's going 99% chance it's going to use pandas data frames as your input. And that's what you saw in the previous solution. So I've done a fair amount of data analysis and data cleaning and stuff like that, and pandas is amazing. I can't say that I've done anything ever outside of Python other than a little bit of R coding or R. I don't know. Some people debate whether R's coding, but whatever. Some R coding, and I don't necessarily like that approach to data analysis, but they also have some cool libraries too. But in terms of like data science, machine learning, anything like that, like Python, at least in terms of the ecosystem, is definitely king. There might be some things that are faster, but Python will. A lot of the backend in Python, especially at this point, is being written in C. So you're just basically using a wrapper language on top of it, especially with those like scientific computing libraries. So there's a minimal amount of overhead, but there is some, but it's not as bad as Python normally is. So I'm gonna open it up because I figured it out yesterday. So yeah, so I don't want to do it as a data frame though, but for I already did this. Forget, can I give it a list? I guess I can just append it every time. Doesn't really matter. Oops. So crab counts dot append np, oh sorry, the length of np dot where x is equal to I, and then the 0th index of that, because it does support 2D arrays. Yeah, that's the same. So return crab counts. Oh, I never used. Oh, it's where crabs np equals I. There we go. Oh, crab. So load crabs is giving us a crab counts, and then for I in oh no, I'd have to do it as a range because I don't, if I iterate through the list itself, it's going to give me counts, and that's going to screw me. Well, actually, I want to use enumerate crab counts, and then it's index value. It's the tuple it gives you. So the index is going to be distance and then count. So I is not defined. R fuel count. So we don't need for crab in crabs because this is implicitly doing it. Did this finish? Oh, no. Whatever. I know it took a while. That's all that I really care about here. So for crab in crabs, let's do it the first way first. Oh, I don't need this anymore. Oh, wait. No, I do. Wait, one sec. So the distance and the count. Oh, I screwed this up slightly. So this is still true. So this is the length. These will be equivalent, but just so it makes sense with... I went back a little too far. Crab counts. Would it be the length plus 1? No, it wouldn't be the length plus 1. And then this is where I do the enumerate. So for distance, count and enumerate, which if it wasn't already obvious, it just takes a list and it iterates through each element of the list, but it gives you both its index. So I guess this isn't distance, but it gives you its index and its value. I'm sure there's constructs in other languages that you can do this, but I don't know off the top of my head. So this is actually position, not distance. So the fuel count would then be equal to... the absolute value of I, which is like the chosen vertical that you're using or the chosen position that you want to test out. So I minus the position. Oh, interesting. So if the crabs are... Wait, no. Did you check to see if the crabs are actually unique? Because they're definitely not unique in the test. Let's see if personal stats loads. It's been temporarily disabled. They're definitely not unique in the input though. Yeah, I mean it's a good it's a good exercise, and B, like you have reason to suspect because they aren't unique in the test file, but the range of the test file is much larger. So if there are duplicates and the actual magnitude that would be possible just statistically within a set this big, like there's nowhere near the number of crabs compared to the range. I wish I could put that in more technical terms, but like the likelihood's relatively low that you're going to have something that would hold up my original solution much more than this solution. But let's continue to benchmark it. So it's absolute position times I minus position times count. Wait, why am I missing? I think that's it. Why? Oh, I think the reason I got this is because I saved mid, and it's not like caching the file you're executing on, or like the required artifacts to that command you're benchmarking. So when I save app.py and it creates an error, like it's gonna screw up the benchmarking process. So max crabs isn't necessary. That's what ran into an issue. I mean, that seems... maybe it wasn't that much faster. I don't know. We'll see. So it was like 1.01 with your solution. I can... Well, it will be fast. No, I don't know. We'll see in a second. And any results that come up from this might be A, my solution, and B, it just might be different in Python anyway. So yeah, it takes a little bit longer because you have to go through and do the counts. But maybe there's a benefit when you run it this way. So calculate fuel will be the same. It's the same thing times count. What? I don't have the printout telling me what row I'm on. So yeah, I don't know. This is going to take a while and it doesn't really matter. So but I think you did bring up a really good point. This would be the more efficient and optimized solution if there weren't unique crabs. So did you check for certain there aren't unique crabs? Or are you just like inspecting manually? Oh, you said it's at least not a ton of duplicate crabs. There may be a few, but not more than a couple. Yeah. But I still think it was interesting. It's a good thing to be thinking about as well, because it's something that with a much larger input file, one that had a bunch of specifically one with a bunch of duplicates, is where this would really shine. Not that I'm necessarily writing for complexity, but time complexity. But if you are, in this case, the second one, I was still somewhat bottlenecked by, like, I felt like it's not taking 1 second to pop out with an answer, or maybe a couple seconds. We're talking about like probably a minute or so. And if you're going for like a good time, potentially spending, especially with debug time, like spending a little bit of extra time making a more optimized solution and approaching it a little bit cleaner, always a good idea. So yeah, I think the last thing that I'm going to do today is look at this recursive solution. Or maybe I bench this for tomorrow, now that I know it. Yeah, so I think I'm going to probably end the stream here shortly, unless there's any questions. Devil Squirrel seems to be the only one typing in chat out of my 2 viewers, but any last comments? But yeah, I'm gonna look at this, try to see if I can figure out a nice way to write this. I want to step my game up a little bit on the stream in the coming days. I want to pivot. I mentioned it a little bit earlier. I want to pivot a little bit away from just trying to race for a really good time, because like these are getting harder, and it's hard to race when you hit a brick wall, which is something that's happened twice so far, where I've ended the stream without completing both parts. And I think that it's also more useful to make this a little more educational. So another thing that I'm trying to do during Cyber Monday, I picked up one of the Wacom digital tablets. So I need to figure out all the apps and stuff on my Mac here in order to do so, but I'm going to hook that up and play around with it. And maybe I can do some like whiteboarding where necessary to like explain some solutions and create a more pleasing visual experience in terms of I don't think it's going to be super useful for Devil Squirrel, but because he's solving them as well, he understands the inner workings of the problem, but especially for new people that might want to be attempting these problems either soon or like looking back on this, preparing for next year or whatever, it's always nice to have some nice like explanations of the algorithm, especially with pictures. Like code is useful and you need the code to execute them, but yeah, having pictures. So yeah, part of it a little bit is the, oh damn, I'm burpy today, probably dinner. But I lost my train of thought. It'll come to me. Yeah, I think part of it might be a little bit like fatigue with streaming, and I've just been busy with other stuff recently. I got some work to do tonight. So I'm going to call it here in just a moment, unless there's any last questions. whatever. I'm going to look at this recursive solution and see if I can write out an explanation that could be useful for people watching earlier. As a result, might start the stream a little earlier tomorrow, prior to 8:30, which is like my normal starting time that I try to shoot for, to go over that and show how you can solve it. Yesterday's in a more recursive manner, and maybe run some benchmarks and or like see if I can actually get a full 256 done, which I feel like it might be really huge. So even overnight, it might not be done. But have some more concrete numbers I can show about like how much better that 2 seconds is compared to the naive solution, and also talking about recursive. And then maybe we can do some extra practice problems. So yeah, I think that's it. As always, thank you to my viewers that are here, specifically Devil Squirrel. I'm his #1 fan now, because he's in here every day, and definitely makes me want to continue streaming. Having that one chatter. If I ever go big, you're getting a VIP, or I'll gift you a sub or something, I don't know. Probably won't ever go big. Mostly an experiment, but we'll see where it goes. Hopefully I will grow into streaming as this experiment through 25 days continues. So yeah, I think that's it for the night. Everybody have a nice night. I'm glad it was an easier problem today, because after my past few days of problems, I needed an easier problem. But yeah, have a good night, everybody. Anyone that's watching the VODs afterwards, hopefully you made it to this point. I know very few people will. But yeah, have a nice night. Adios.